Hi, sorry again. I'm Kelsey. I'm the program assistant here at the Bronx Zoo in digital learning and engagement. And I just want to make sure everyone set up their audio wizard. You should have, since everyone has indicated that they can hear me. If you haven't, please do so now. Again, welcome. Today we're going to learn all about American eels with our scientist Jake LaBelle and our educator Paloma Krakower. I just want to give you a little bit of background before we delve too deeply into the science here about who we are. So this webinar series is presented by the Education Department here at the Bronx Zoo, which is run by the Wildlife Conservation Society. The Wildlife Conservation Society is an organization working locally and around the world to protect wildlife and wild places. WCS is science, conservation, action, and education to inspire people to value nature. In addition to working around the world on numerous conservation projects, WCS runs the 4 zoos, including the Bronx Zoo and the aquarium here in New York City. Through these facilities, WCS has reached about 400 million people. So the education department here runs programs for all ages, from BD programs like this, where you're learning as a teacher, all the way to summer camp and everything in between. So I hope that gives you a little bit of background information about who we are and why we're doing this. So I'm glad you're all with us. Before we get started, I have a couple of things I just want to go over about how to use this platform. There are some cool interactivity features, so I'm just going to point them out. This one is talk here, which I'm circling. We might have opened it up to your microphones to have you ask questions toward the end, but we usually just keep that to typing on the chat room. We have these interactivity options. So here, right here, I'm zoomed in over here. So this smiley face here has all of these emotions basically. So they let you tell us how you're feeling. If you feel like we're going too fast or too slow, you can indicate that. If you think something's funny, feel free to share. There's also this raise your hand tool. We may ask you to raise your hand in answering a question at some point during this, or if you have an issue, you can raise your hand as well. And finally, we have our polling options. It might change throughout the course of the webinar. Right now, you see, if you look on your participants on the left-hand side of your screen, you should see a little A. That's going to be a drop-down menu. If one of our moderators wants to ask you a question in a multiple choice format, that's where they'll have that. That's where you'll answer that. And finally, feel free to chat anytime in the chat bar. You can ask questions, ask for clarification, anything like that. Feel free to use. And so let's see where everybody's from. Here on this right-hand side of the screen here is an example. Everyone should have this toolbar on the left-hand side of their screen. This second button here, that's your laser pointer. So if you click on that, you should appear with a little sun on your screen, and you can click that anywhere on this map, and that will show me where you are. Yep, I see somebody doing it right now. There's also, you can change the shape of that laser pointer if you feel so inclined. All right, great. Looks like we have people from all over the country joining us tonight. Awesome. I'm glad that you guys have got the interactivity features here. Great, thanks. So again, don't feel scared to type something into the chat box if you have an issue. We're here for you. And without further ado, I think that's gotten me on to my explanation, and I will get to the science. So our first presenter is Jake LaBelle. He is a scientist here at the Wildlife Conservation Society, but I'll let him introduce himself. Ready, Jake?
I'm ready. Can everyone hear me? Hello, hello. Oh, yes. Okay, great. Hi there. Sorry about that. Thanks, Kelsey. My name is Jake LaBelle. I'm a scientist with the Wildlife Conservation Society. I work in the New York Seascape program, which is a program based at the New York Aquarium out on Coney Island. And the New York Seascape program began the New York Seascape program started in 2010. It was in an effort to get WCS working in its own backyard. We're based here in the Bronx, even though we're a global organization. We have research projects going on all over the world. And we decided we wanted to start getting some work done right in our own backyard. And the reason we chose New York, aside from being the global headquarters for our organization, is that there is a wealth of wildlife here. There are over 330 species of fish. There are 26 species of sharks, 15 whales and dolphins, skates, rays, sea turtles, invertebrates like horseshoe crabs, dozens of seabirds, even corals. People think of corals as a more tropical species that is just limited to the Caribbean or Hawaii, but we have corals right here in, not necessarily in New York waters, but just off our shores, about 90 miles southeast of New York City. There are corals that live down at the bottom of the Hudson Canyon. So just an incredible wealth of biodiversity here in the waters of New York. And tonight I'm going to talk to you about one in particular, the American eel. The American eel is an incredibly fascinating fish. They are found all the way from in the north in Canada and Greenland, all the way south to South America. And this is all one population of eels. All of these eels start in the same exact place, which is here in the Sargasso Sea. And from there, they have just an incredible journey that lasts decades before they return home to the Sargasso Sea to spawn again. And I will describe each of these life stages now. So eels are born in the ocean, as I mentioned. They are a diadromous species. By show of hands, does anybody know what diadromous means? Sorry, raise your hand if yes. I'm guessing a ding means yes. I'm not sure. All right, well, diadromous means, okay. Diadromous means that a fish spends part of its life in freshwater and part of its life in saltwater. So this is a sort of common trait for some fish. Salmon is the most famous example. But eels are a little bit different. They're actually the exact opposite of salmon. So they're born out in the ocean, and then they spend most of their lives living and growing in freshwater before they return back to the ocean to spawn again. And that is where we find our little leptocephali, which are eel larvae. So these larvae, they hatch out, and they get to be about, I don't know, 4 to 4.5, 5 centimeters long. And they are not really able to swim. As you can see here in this picture, they're sort of shaped like a leaf, like a really long willow leaf. And since they don't really have motor skills, they use that body type to sort of drift on oceanic currents. The one that brings them here to us in New York is the Gulf Stream. And they will drift on the Gulf Stream for about a year before making it up here to the Northeast. And all along the way, they're starting to transform. But as they're going so from the Bronx River here to the Sargasso Sea is a distance of about 1,500 miles. If you want to compare that distance to how far people would have to go, that would be equivalent to walking all the way around the world over 7 times. Or if you are like me and you kind of like space, that would get you about 1/4 of the way to the moon. And these eels will do this twice in their lifetime. And I'll get to that. So as I mentioned, as they're going on this journey, drifting northward, they're transforming the whole way. And as they get closer to shore, they'll transform into their second life phase, which is a glass eel. Glass eels, they look almost exactly like their their adult counterparts, except for they're completely transparent, which is very cool if you look at them, because you can basically see their eyes and just a very long little spinal cord, and then everything else you can see right through. They start swimming into estuaries and streams and rivers in late winter, early spring up here in the Northeast. And at this point, they actually shrank a little bit. So to get to that glass eel shape, they had to sort of condense their bodies a little bit. And as they start moving into rivers and streams, they start to darken. When they're out in the ocean, it's better off being sort of a clear, translucent coloration, because it's harder for predators to see them out in the bright blue water. But as they come inshore, the waters tend to darken, so they actually take on coloration to be able to match like the stream bottoms and be less visible to their predators. This is a very vulnerable stage for eels, not the least of which to humans, because they are actually very, very valuable in this stage. As I'll get to this a little later, but glass eels, when they're caught, can actually fetch a price of over $2,500 a pound. I'll go into fisheries a little later, but it's really just incredible that they're that valuable. So as they start to take on their coloration, they're transforming into their third life stage, which is elvers. Sizes of elvers can vary. As you see in these pictures, this one here is just coming out of the glass eel phase. You can still almost see through him a little bit. And then this one over here is still an elver, but you can see his body has gotten a lot thicker. He's got a little more defined head here. And he's well on his way to becoming an adult eel. This is sort of the main movement phase for young eels. They'll spend much of their time in this stage swimming upstream as far as they can, pretty much until the following winter, when they'll hunker down and sort of bury themselves in the substrate in the bottom of the river, and basically hibernate like bears or other large mammals on land. And then when they come out the next year, they're usually in the yellow eel stage. And this is the main developmental stage for eels. They can actually be in the stage for up to 20 or 30 years before they mature and head back out to sea. They can get very large. They can be over 3 feet long. And they'll eat just about anything. When they're smaller, they'll eat other fish eggs, insect larvae, and as they get older, they'll eat crayfish, smaller fish, pretty much anything that's smaller than them that they can grab. And this stage of eel is the main target for our commercial fisheries and some recreational fisheries, but I'll get to those fisheries again in a little bit. So after the eels have spent enough time in the rivers, no one's really sure why they choose to enter the last mature phase, which is the silver eel phase. It actually varies quite a bit from among individuals. Eels will grow at completely different rates depending on the individual, a lot like people. Some of them mature at very small sizes. Generally, males are under 40 centimeters long, and then just about anything over 40 centimeters is almost always female. And it can take them varying amounts of time to get to these sizes and ages. But when they do, some signal inside them tells them to make this last transformation, and they'll turn into this very metallic silver color. So this eel right here, actually, that I'm holding in this picture, is the very same eel as in this picture right here. I'll get into how we know that a little later on, but so this eel right here actually silvered over the course of a couple of months, and we assume went back out to sea. So to get ready for this journey, they'll undergo a couple of different body changes. So the coloration is once again to help them avoid predators. So when they get out to the ocean, they have this counter shading which means they have a very white underbelly, and then they're very dark on top. So when predators are looking down at them into the depths of the ocean, they don't really see them that well, and if they're looking up, they'll just see, against the sunlight, they'll just see this sort of amorphous white blob. Their eyes will also get a lot bigger. And one of the most fascinating things is that they won't eat at all. They won't eat at all on their trip from the rivers back out to the Sargasso Sea. So they really don't want any excess weight. They really just want to transform everything into energy. So their intestinal tract and their digestive tract actually breaks down, and they're able to reabsorb that as energy as they're going. Sorry, here we go. There we go. So in 2012, there was a stock assessment by the government that found that eels were at an historic low status. We call that depleted. Boy, this is a lot of words here. Sorry about that. In both 2007 and 2015, eels were proposed for inclusion on the endangered species list, but unfortunately both times they were denied. And the reason for which was that although the stock is depleted, it is now stable thanks to some management efforts. Basically, it's a lot of very strict restrictions on glacial fisheries that I mentioned before. Those are only legal in Maine and South Carolina. There are very strict quotas and strict fishing seasons where there are only a couple of weeks out of the year that fishermen are allowed to go out and harvest them. The reason that these fisheries are so lucrative is that it's actually the glass eels aren't sold here. They're sold to Asian markets where they're grown up into adult eels, and then once they're grown into yellow eels, they're then sold to the sushi trade. American eels are very closely related to both European and Japanese eels, both of which are even more depleted than our American eels. So the Asian markets have basically turned to the American eel as a source for the eel, and they're mostly in the sushi trade. For yellow eel fisheries, there are also very strict quotas. These are there's one overall coast-wide quota that is divided amongst the states based on their historic fishing practices. So based on the amount of landings, historically, each state is allocated a certain amount of the catch per year, and there's still a very small amount of a small fishery for silver eels that is mostly in the Delaware River in Pennsylvania and New York. So as a result of all these management actions, the U.S. Fish and Wildlife Service found that eel populations, though very depleted, are currently stable. They're stable enough not to warrant inclusion on the endangered species list. In addition to all of the fisheries, commercial fisheries, there is a very small, though not very significant, recreational fishery. But one of the fisheries that could be causing a lot of problems is the bait fishery. American eels are excellent bait for striped bass, which up here in the Northeast is a very, very popular recreational fish. And they just go crazy for live American eels. And there's very little data on exactly how many eels are caught in the bait fishery. It's an area where we definitely could use a lot more data on just how many eels are being taken through that fishery. In addition to all the fisheries, there are a lot more threats to eels than just what people are taking. There's habitat loss, predation as other stocks start to come back, like the striped bass. They are eating a lot more because there are a lot more of them. And eels are a very, as I said, a very favorite prey item for a lot of fish species. Food web alterations, turbine mortality. As eels are coming downstream, they're a lot of times they get caught up in hydropower turbines. They get sucked in through the intake valves and then just kind of get cut up along with a lot of other fish as they're coming down. Environmental changes, toxins and contaminants. A lot of our rivers and streams, especially here in the Northeast, have been heavily used. And it's eels are generally very hardy, but it's unclear whether or not they're becoming more susceptible to disease or to predation because of some of the toxins and contaminants that are in our waters. And the major problem with all of these is, as I mentioned, the eels will swim back out to the Sargasso Sea to spawn, and so all of these eels that are being either fished or eaten, they're all being caught before they're able to spawn. So that's a huge problem for the eels there. But really, one of the biggest problems for eels and other diadromous fish as well is dams. This is a map of all the dams in New York State that I think are over 12 feet tall. This is from the New York State dam survey, and they only survey dams that are over 12 feet tall. And so there are actually hundreds, if not thousands, more dams that are even shorter than these. It's estimated that there are between 5,000 and 6,000 dams in New York alone. And these dams will block the upstream migration of the glass eels and elvers, and it prevents the eels from getting to their freshwater developmental habitat. So we, in the New York Seascape program, are working on the Bronx River. And on the Bronx River alone, it's a 23-mile stream. It's the only freshwater stream in New York City. There are 9 dams on the river, and they range in height from 14 feet at the first dam down in the Bronx. Oops, there's my laser pointer. Nope, still not. There we go. Okay. This first dam down in the Bronx is about 14 feet tall. And they range down to these dams here in southern Westchester County are only about 3 to 4 feet tall. But for a tiny glass eel, it's only about 40, 50, 60 centimeters tall. That's still a pretty big barrier to try and surmount. So the objectives of our study here in the Bronx River was to characterize how American eels use the Bronx River, assess the impact of all of those dams on young of the year, which are your glass eels and elvers, and yellow eels, and provide eel passage once we figure out what the populations are. And so over the years, we've had a couple of ways of doing this. In 2012 and 2013, which was the first few years of our study, we used fyke nets, which are these large nets that basically block off with a couple of wings a certain stretch of the river, and it funnels down here into a little capture device. And we had those set up below the first dam on the river and the second dam that's actually located on Bronx Zoo property. And what we found was we had decent catches in the first dam, a couple of hundred over the course of about a month and a half, and not a single glass eel or elver was caught in the net below the second dam. So that told us that there were not a lot of eels making it over that first dam, and so we decided to try and help them out. In 2013, we tried to build a very low-cost, low-tech eel pass, which was basically just a very long PVC pipe with a little bit of baseball netting strung through it that we draped over the side of the dam in the hopes that the eels would be able to kind of scamper up the baseball netting. glass eels and elvers are actually really talented climbers. If they have a surface, sort of a rough surface, and just a little bit of water flow, they actually can scale vertical surfaces. And they can climb pretty high, but as you can see, this is a picture of the first dam. That's a very tall, very violent cascade of water. So any small eels that are trying to sort of scurry up here would easily be swept off. And we were hoping that they would be able to use this baseball netting. We sort of tried to control the flow of water on that side, but it didn't really work so well. We only had one eel that was able to climb up the netting, and that was even when we were placing eels that we had caught on the fyke nets directly onto the baseball netting. So we found that we needed something a little more advanced, and I'll talk about it in a little bit. But a few years down the line, we actually figured that out. We also wanted to see how far upstream small eels were really able to get. And so the fyke nets were very labor intensive, and we switched to a much cheaper, much easier way of sampling, which are eel mops, or medusas. They look like this crazy Halloween wig, but they're actually very cheap, very easy to make, and they make for a great citizen science opportunity. Pretty much anybody who's close by freshwater, stream, river, can build these, and they do a pretty good job of attracting little eels. They basically act as a temporary refuge for eels. The young eels like to swim upstream at night, again to avoid predators. So during the day they'll hunker down either under leaves or in the mud, or hopefully in our eel mops. So for the last 3 years, we've been monitoring eel mops below the first 6 dams on the river. So we had eel mop, a set of 3 eel mops each below these dams in the Bronx, and then also these dams here up in Westchester County. And what we found was basically that there are many eels. We caught hundreds of eels down here at the first dam. We had tens of eels here at the second. And then after that, we had 1 eel here at the third dam, 2 much larger elvers here at the fourth dam, sorry, and 2 very small yellow eels at the fifth dam. So basically, this first dam down here is a very large impediment to upstream migration of the young eels. And so we wanted to look at how the dams affected older eels, the yellow eels. And so to do that, we use a technique that's called electrofishing, which is sort of exactly what it sounds like. You wear this Ghostbuster-looking backpack on your back, and it connects to a little wand that stretches down into the water with a little steel ring at the end of it, and it actually sends a little electric shock into the water that'll temporarily stun the eels and any other fish that happen to be around. And when they're stunned, our faithful netters will dive in and hopefully scoop them up before they recover and swim away. So when we catch the eels, we temporarily anesthetize them using just ordinary clove oil, and we implant them with these small electronic tags. It's really difficult to see here in this picture, but if you look just right where this man's finger is right here, there's a tiny little electronic tag that doesn't require a battery. If you use one of these handheld readers here, it actually sends a charge to the tag, and the tag will send back its ID number. So by tagging these eels, we were hoping to see if any eels move between the dams on the river, And if any of the larger eels are able to actually scale the dams as well and move farther upstream. And this also allows us to, over the course of years, if we recapture the same eels, we can get an idea of their growth rates and a little bit on survivorship as well. So what we found with the yellow eels, if we go back to my map here, as with the glass eels and elvers and the eel mops, there were a lot more yellow eels down here below the first dam. And as you move upstream, we had fewer and fewer eels. And not only that, as you move past each dam, eels are getting larger and larger. Sorry. Yeah, so the eels are getting larger and larger as you move upstream. These eels are generally thought to be older, and like I said, once they get beyond about 440 centimeters, they're almost always female. And one advantage to being a larger female that you would find farther upstream here is that larger females are able to produce more eggs. So it's a good thing to have a lot more larger eels. But unfortunately, these dams are preventing the eels from migrating farther upstream and reaching their sort of maximum size. So in order to help them, last year with help from the New York City Parks Department, we were able to build a little more complex eel ladder. As you can see here in the picture on the right, there's two sides to it. This left-hand side here is made up of a sort of a fibrous little mat that smaller glass eels and elvers can use to sort of scurry up. And then on the right side, it's kind of like a pegboard. So larger eels can actually just sort of shimmy their way through these pegs and work their way up. This little spray bar here provides a constant source of water, so they never dry out. Unfortunately, this pass doesn't reach all the way up to the top of the dam. It actually empties into this collection bin about 2/3 of the way up the dam. So it requires us to go in and help the eels out a little bit. We actually empty this every day and transport the eels up the rest of the way up the dam. We figure if they got that far, then they earned it. They can get a ride the rest of the way. The hope for us is, though, in the future, that we can extend this eel ladder and get it so it actually reaches the top of the dam, and the eels won't need our help at all. And looking even farther down the line, we hope to construct similar structures at each of the dams farther upstream, so we can try and restore these eel populations to a level that's closer to what they historically were. Yeah. So my take-home messages here. First, just a huge thank you to all the people that help out with all this research. This is basically just a fraction of all the people that have helped out over the years. Last year alone, we had, I think it was 43 different volunteers for the electrofishing. So really, it's a team effort, and I couldn't have done it without all these folks. Yeah. So that's all.
All right, thank you so much, Jake. We're going to open it up, if that's okay with you, for some questions, if anyone has them.
Sure.
So if anybody has a question, feel free to type it in that chat box. I'll wait a minute or two to see if anybody wants to ask anything, and then we'll move on to Paloma's portion.
So yes, Kristen, eels do bite, but they don't have teeth, or what teeth they have are not sharp at all, and not even close to sharp enough
Jake,
to be able
it
to.
looks like we have a question from Kristen. She said, do American eels bite, or could you just pick one up?
Yes, eels do bite. They don't have big teeth though. They hardly have teeth at all. So when they do bite, it just feels like something sort of kind of gumming on you. It's very rare though. I've only been bitten once, and it really doesn't feel like anything. Their jaws aren't all that strong. I see a question from B. Stewart. How many eggs are hatched at a time? Again, it depends on the size of the female. Smaller females can hatch anywhere. It's a lot. It's like many fish. Eels are what's called broadcast spawners. So with mammals, we invest a lot of time and a lot of effort into very few young. So people, it's usually one baby at a time. Like elephants is one at a time, and there's a lot of parental effort that goes into raising those offspring. For most fish, it's sort of the opposite. They just rely on numbers. So they'll throw out as many eggs as they can and just sort of hope that a few survive. So for eels, smaller females, they lay, I don't know, tens of thousands of eggs at a time, and the larger ones can lay hundreds of thousands or more at one time. Let's see. So Julio had a question on the Asian demand for eels and why it dropped in the 80s, then jumped in price and demand. So Asian markets heavily used European eel for a long time in their markets, and Europe actually closed their eel fisheries in the late 80s or early 90s, and that's really when the market shifted to American eel, was after the European market closed. Let's see. Another question from Patricia. Have there been any studies done in the bays in the area? In the area, I'm guessing you mean New York. Not specifically for eels. There have been some studies done in the Hudson River, in tributaries in the Hudson River, but I'm not sure there have been studies done in any of the bays. A great question from Cecilia. So she asked if there's a formal citizen science program to get classrooms involved in. Not yet. There soon will be. It's something that our program is working on right now, and we hope to have it. We are working on some protocols, and we hope to have instructional videos and those sorts of informational tools ready in the next few months or so. So check back in later on this summer, and hopefully we will have something up and running. Let's see. Another question from Kristen. Do you think the populations of eels are good enough to not be considered endangered, or would you think that they should be listed on the endangered species list? That's a difficult question. One of the big problems with any fishery science and trying to figure out the status of fish stocks is that it's a lot harder to get accurate population estimates for fish. For most land animals or birds, it's easy to go out and survey. You can just sort of look and see like oh, there, I can count however many deer or whatever it is you're surveying. With fish, it's much harder. You can't see into the water. You're sort of limited to what you can catch. There are statistical models that are used, but a lot of the parameters that go into those models are still unknown. There's still so much that we don't know about the life history of the eels. For instance, it was only early this year in January where we actually confirmed that adult eels return to the Sargasso Sea to spawn. It was always assumed because scientists had done plankton tows, and they had pulled up eggs and freshly hatched larvae. But no one has ever actually seen American eels mating. It's never been witnessed, so just judging by the location of the eggs and larvae, we're just assuming that that's where the adults go to spawn. But just earlier this year, some scientists up in Canada attached a satellite tag, an archival satellite tag to an eel. They attached them to dozens of eels, and one of them was actually tracked all the way back to the Sargasso Sea. So it's actually the first time we have confirmed evidence of eels going back to the Sargasso Sea. But it's just another example of how little we really know about American eels, and it makes it a lot harder to judge exactly what their population is at this time. So we're sort of forced to just look at trends in commercial catches, in independent fishing surveys. So it's very difficult. Kelsey, how are we doing on time?
You should be okay for a couple more minutes if you want to answer those last two questions.
Okay. A question from Patricia. What were the findings in the Hudson River? So the New York Department of Environmental Conservation has been running a very successful monitoring program in the Hudson River and the tributaries. They actually get much higher catches than we do in the Bronx. They're using fyke nets and eel mops like we were, but their numbers are a lot higher. I don't really know the results of their studies. It's sort of an ongoing project. So they've been doing that for quite some time, actually. I think they started in 2009 or so. It may be a little hard to find, but I know there's a link on the DEC website. They have tons of great information. They also have a citizen science project that they have up and running in the upper tributaries of the Hudson River. I'll see, Kelsey, maybe we can find that link and add it to the list of helpful links that we had on the website.
Sure, yeah, I can add that, or I can share it right here in the platform.
Okay, great. And the last question from Julio, what kind of experience is needed to help out or volunteer? None, really. As long as you're willing and able to walk around in a river, get wet, get dirty, maybe get a little bit of a shock if you're electrofishing. No, not really. It's yeah, our volunteers, a lot of our volunteers have no experience electrofishing or eel mopping. Yeah, so it's sort of a no experience necessary, just a willingness to be outside all day, get wet, get dirty.
All right, great. Thank you so much, Jake. I just found that link for the Hudson River DEC Eels program, so I'm just going to add it in here into the chat box if anybody wants to look at it right away.
All right, great. Thanks.
I would love to let people continue asking questions, but I want to give Paloma some time. So we're going to move on to our next presenter, who is Paloma Krakower. She's a coordinator here at Professional Development, and I will let her take over from here. Take it away, Paloma.
Hi everyone, good evening. So happy to join you tonight. Can you just give me a quick check that you can hear me before I move forward? Awesome. Okay, so like Kelsey said, I am a coordinator of professional development here with WCS, and this evening I have decided that we are going to use maps and geotours to create a natural history narrative. So we are going to be working with Eli, the American eel. So just so you know, it is targeted towards upper elementary grades 3 through 5. The reason I decided to go this route is because in the past, traditionally, the New York Aquarium has done some teen programs with eel monitoring, so I wanted to give teachers or educators the opportunity to target younger grades as well. That being said, of course this lesson can be adapted for other ranges, which if we have time I will get to at the end of the presentation, and there's definitely opportunities for extensions over multiple class periods. Okay, so this evening our objectives are to track the typical life cycle and migration path of American eels, use latitude and longitude coordinates to determine specific geographic locations, apply cultural cues as a means to build mapping skills, explain the purpose of a map scale, and use web-based interactive technology to aid in the development of students' spatial thinking skills. So we are going to be utilizing National Geographic's interactive web map this evening. So I'm going to be providing you with a link. Unfortunately, I can't stream it live through the platform, so I will give you a link to a bookmarked map that I have created for the purposes of this narrative, and feel free to explore while we go along, okay? Before we get to all of that, I want to briefly hit some standards. As if any of you are formal classroom teachers, you know how important standards are. So I won't go into detail here, but essentially we can use characters to draw on specific details. We can use evidence to really exemplify and take away main points from text. And this is true in literature and also informational text. Let's see. Same thing with writing. We can use narratives to help create imagined experiences, which is something exactly that my narrative will be doing with you today. You will have an opportunity to use this same skill with your students if you want, or you can actually have them create more of a formal, informative text based off of the information that they get. And of course, we want to get New York State science standards in there. I won't read those to you, but we also have some connections to NGSS as well, talking about patterns, cause and effect. Scale is really a big one, structure and function, stability and change. And because we are using mapping skills, I think it's very important that we recognize the social studies standards that we are going to hit as well. So obviously geography is a big component of that, using local New York State geography to help tell our narratives, and I will let you go back to these specific standards on the recorded session if you so choose, if you want to see more ways that you can hit New York State standards and or broader national standards. Okay, so really quickly, I just want you guys to use the poll function on your toolbar so we can get a sense of who you are tonight. So if you can use that poll function, I'm really curious to see who we have in the audience. So we have a lot of general knowledge enthusiasts, classroom, high school, middle school, okay, informal ed. So we have quite a range, which is nice to hear. So welcome everyone. I hope that this is an enjoyable experience for all of you. Okay, so what I want to say is that even though I'm targeting younger audiences, it's always beneficial to have a word wall in your classroom or whatever audience you're working with. Even though I said this is targeted to 3 to 5 grade spans, these specific vocabulary words might be a little bit challenging for that audience group, but I did want to include them in case you also work with older audiences and or want to challenge your current group of students. Okay, so I'm going to go ahead and post that link to my National Geographic map there. Just so you guys know, because I can't go through the functions of the map itself during this webinar, if you go to this website here, they have great tutorial videos on how to use all the different functions of the mapping skills. So it's a great tool base for any of you guys who work in the classroom. Okay. So I quickly want to point out a couple of features for those of you who are going to be exploring while we go through this. Here on the upper right-hand corner, you will see the longitude and latitude readings over here. So traditionally, if we were using a classic map, you guys would have to figure out that the longitude and latitude lines yourself, but luckily in the interactive map, if you just scroll over these different grids, this number will change and it will tell you specifics. Okay. Also, the toolbars that I used throughout this process was this one over here, which is the marker page. What else? This one is also important. That is a ruler, so you can actually mark different points along your path and also measure how far you are going. I chose to include a surface layer of ocean currents, and you can choose different layers on your map on these tabs over here. Let's see. So just to reinforce, this little button over here is talking about, that's where you turn the longitude and latitude on. Also, this is where you will see the map scales. As you zoom in and out of the map, the scales will be changing as well. So if you are using this with your students, always remember that the more you zoom in, the scale of the map is changing. So it's not static. And these are examples of the different markers. Okay. So I have decided to create a narrative for you guys. I apologize in that I'm actually going to be reading it to you. Because we cannot go through the map together, I do encourage you to use the bookmarks that I have created on that link so you can follow around and explore. Okay? So let's begin. So this is Eli the Eel's epic journey. So it is January somewhere out in the Atlantic Ocean. A new generation of American eels has been born. Millions of American eel eggs float on the ocean surface waiting to hatch to begin an epic journey to the Americas. American eels are quadrupedous fish, which means, oh, sorry, I said that wrong, but but they spend the majority of their lives in fresh or brackish waters and return to the sea to spawn and lay their eggs. Wonder what their journey would be like? Let's follow one of these American eels, Eli the eel, on his journey throughout his lifestyle. So you will plot the path he follows on the interactive map provided. At each stop that Eli makes, drop a marker to track his migration in different stages of his life cycle. You will meet some friends of Eli's along the way and pick a different marker to note where they end up. Students will be using latitude and longitude coordinates and cultural cues to determine the spots along Eli's journey. And this activity will focus on mapping at different scales. This can be international, national, and local. So I'm going to read the story to you out loud, and remember to follow along on the map. Okay, so let's begin here. So remember, I am super zoomed out at the moment, but feel free to explore with the different bookmarks on the interactive map. Okay, so Eli and millions of other eels, still in egg form, are spawned or laid at the following coordinates: 30 degrees north and 55 degrees west. Where are Eli and his friends born? So for those of you who are actually exploring, feel free to type in the chat box where Eli is spawned. Okay, so because we have already gone through Jake's presentation, right? Stuart, thank you. We know that Eli is born in the Sargasso Sea. So another cool thing about the interactive map is that you can attach photos to different markers. So essentially you can use this little icon over here, and you can include web links to attach photos to these markers to give it more of a specialized touch for your students as you're using it with them. Okay. So Eli has turned from an egg to a larva. You can see right through him because he is transparent and he is shaped like a leaf. Eli doesn't live very far down in the ocean. He lives on the surface. Although he is not a surfer, Eli is totally rad. He rides the ocean's currents in the Sargasso Sea, just drifting along effortlessly. He has been riding the currents for 4 months, and it seems he is headed for the following coordinates: 26 degrees north and 80 degrees west. It is said to have delicious ropa vieja and is sometimes called Little Havana. So for those of you who are looking at the slide, you see that gets us to very close to Miami there. And I chose to go that way just because I thought that could be a cultural cue which you could incorporate with your students, although you could modify this however you want. If you're doing a geography unit and you have different natural resources that you're studying, or state capitals, for instance, you could easily change these coordinates or these cues to fit the unit of study that you are doing right now. Okay. So on his journey to the shores of Little Havana, a strong warm water Gulf Stream current drifts Eli back to sea. Oh no, watch out! That was really close. Eli was almost eaten by a big fish. It has been about another 5 months out at sea. He has had his friends Emily and Eric the eels with him. Emily's current slightly changes direction, and she ends up going to the Chesapeake Bay. What are the coordinates for the mouth of the bay? So for those of you who are on the map right now, can you plug in degrees of longitude and latitude for the Chesapeake Bay? I'll give you a minute to figure that out. 36 degrees and 77 degrees, 36.77 degrees latitude from Kristen. Thank you very much. So this is a great way to reinforce that your students are learning these longitude and latitude skills as well. So Emily has grown more than Eli and Eric. She is now 1 to 2 inches long, has fins, and is shaped like a snake. She has metamorphosed into a glass eel. Emily stays in the brackish waters of the Chesapeake Bay for over 20 years. So an interesting way to use narratives is that you can easily talk about different natural history phases. So with American eels, as Jake said, their development is very individualized. So sometimes it takes eels years to develop, and other times it happens very quickly. So while Eli might be headed to New York, Emily stays in the Chesapeake Bay area, which means she has grown up faster. And she is going to stay in this one spot for over 2 decades, whereas that's not necessarily the same migration path as different eels. Okay, back to this story. Okay, so the next slide is, at the same point that Emily leaves, Eric is swept up by another current that brings him all the way up to a country whose name is the inverse or opposite of what it looks like. It is very cold and is covered with ice. Its coordinates are 70 degrees north and 40 degrees west. Where did Eric end up? So, yes, thank you, Kristen. He ended up in Iceland. I'm sorry, Greenland. See how I got that all confused there? So this is great because it gives this mapping interactive, gives you the flexibility and opportunity to see the whole potential migration path of the American eels. If you wanted, you could have also gone into its more southern ranges as well. So I chose to go to its most upper north ranges, but you have the flexibility to create the narrative however you want. Okay. So Eli is still at sea when Eric and Emily leave. It takes him another 3 months to reach the shore of the Empire State, during which time he has metamorphosed into a glass eel. He sees a giant lady holding a torch that is made out of copper, the same as pennies, but she is green. Where is Eli and what are his coordinates? So for all of us adults right now, we know that he has been sitting side by side to Lady Liberty here in New York City. So it's a great opportunity to transition from more international scale to a local scale. And I wanted to choose New York because this is where the New York Seascape program is based, and our WCS is 5 parks. So that is why I chose to use New York here. Okay. So he has traveled over 1,000 miles. Eli was one of the lucky ones. He arrived with a big group of other glass eels in New York City, but many of his travel mates were captured by fishermen and now are part of your sushi roll. Excuse me. Eli continues to move north in search of freshwater rivers to call home. He leaves Lady Liberty to travel up the East River. Being this small, he has to dodge many predators that could eat him along the way. Luckily for Eli, he takes a left onto the Bronx River, and organizations such as WCS have eel mops to provide safe harbor and habitat for Eli to hide from predators. So from this slide here, you can see the distance Eli has traveled just from Lady Liberty up to the mouth of the Bronx River here. And then you can see I have zoomed in and the scale of the map has changed again. And this is a picture of Jake and his colleague Mary Kimheim here working with the eel mops. So Eli is very lucky that he has that eel mop there to protect him and provide a safe habitat. Okay. Another year passes, and Eli transforms again. He is now an elver and about 3 inches long and is brown in color. But he will continue to grow. Eli finds himself close to a place that is home to many animals. Some roar, some squeak, and some squawk. Where is Eli near, and what are his coordinates? So, once again, I have used that cultural reference here to indicate that he is near the Bronx Zoo. And we have this picture here to coordinate that he is now in the elver stage. So, we're going to continue now with the narrative. Oh no! There seems to be something blocking the river. Can anyone guess what it is? That's right, it's a dam. It was built in the 1600s to power a mill that made flour. However, now Eli and other fish's natural migration path is blocked. They cannot get from one side of the dam to the other. Eli likes a challenge, so he decides he's going to swim up the dam. This proves to be a little too hard, so Eli decides to leave the water and try getting over the dam by climbing the rocks and then traveling overland on a damp, rainy night to get to the other side. Like most fish, Eli breathes through his gills, but he can also breathe through his skin. This allows him to leave the water for several hours and travel on land. Eli traveled over rocks and land, but many of his migrating friends decided to cross the dam via the eel ladder. It is a ramp that allows his friends to safely travel up the dam to the other side. So I have a New York City Parks map here of I believe these are the lower 2 dams that Jake was indicating on his previous map. Hopefully I am correct there. If I am not, please feel free to chime in, Jake. But we just demonstrated not only some natural history facts, but also local history in that in the 1600s, this area was used for producing flour, and that is why the dams first came. So in terms of industry and economics, this could be a nice insertion of a history lesson as well. And you can talk about how the progression of different technologies was helpful in different areas, and also what challenges those technologies pose to us now. Okay. So, Eli has safely crossed the dam and continues his journey upstream. As he passes, he hears cheerful yells of excitement. There are people throwing black caps in the air, and they are wearing black gowns with rams on them. Where is Eli passing by? For any of those of you who are from New York, do you have a clue of where I am talking about? So if you do, put it in the chat box there. So once again, there are people throwing black caps in the air, and they were wearing black gowns with rams on them. Does anyone have an idea of where I'm talking about? A helpful hint is very close to the Bronx Zoo. Kristen, I appreciate the honesty. So, Fordham, yes, Cecilia. So I was talking about Fordham University, which is very, very close to the Bronx Zoo and also the New York Botanic Garden. So we share the Bronx River, sections of the Bronx River with both of those institutions, and that we do our river monitoring. So I did want to incorporate another cultural cue there. So he travels until he reaches the following coordinates: 41.1 degrees and 73.7 degrees. Where is Eli? And as the picture indicates here, he has made it to the Rye Lake. So he has once again metamorphosed into a yellow eel. He is not sexually mature, meaning he cannot have offspring yet, but he is much larger in size and is no longer at the bottom of the food chain. Eli is nocturnal and is most active at night, feeding on small crustaceans, frogs, and other fish species. Eli spends the next 20 years living in this reservoir. So the reason that I chose this particular reservoir or lake is kind of arbitrary, but when I was using the map feature, I just followed the Bronx River along until it came to a large water body. So once again, if you are using this with your students and you are not sure of geography in your local area, it's a great way for you to really zoom in and look at the geographic and physical layout of your area so you can follow different streams and rivers and give students the opportunity to speculate where these animals might end up. So I see Kristen has a question here. They don't lay eggs until they are silver eels is correct. So at this phase, Eli, even though he's a yellow eel and he's 20 years old, he has not laid any eggs at this point. Okay. And last but not least, we have our final point. So Eli has metamorphosed for a final adult stage of his life. He is now a silver eel. Sorry, forgot to change the slide. And he is 3 feet long. Everything about him is bigger. Bigger eyes, bigger fins, thicker body with more fat. He is ready to find a mate. But before he can do that, he must make a long journey to 26 degrees north and 40 degrees west. Where is Eli headed? I've jumped the gun a little bit with this slide. You already know where he is headed. But for the purpose of your students, it could be a great way to incorporate slightly different coordinates so they're still using those skills to find that he's headed back to the Sargasso Sea. Okay, back to the narrative. This is the only place where Eli and all his distant relatives can spawn their eggs. It is September and Eli has begun a multi-month journey back to the sea where he was born. He is determined to dodge fishermen and predators such as eagles because he will only get one chance to mate once in his lifetime. It is now January, and the very tired Eli has finally arrived back at the Sargasso Sea. He hasn't eaten anything in months, but he has met a lovely eel, Ella, who grew up in Indiana. She, too, had the same journey as Eli. All American eels spend the majority of their lives in fresh or brackish water and then return to the sea to spawn. Eli and Ella have hit it off, and they laid their own eggs. It will be up to Eli and Ella's children and grandchildren to keep the American eel population healthy. They will eventually make their own grand adventure out of the Sargasso Sea and back to the United States or beyond. So as you see there, I put a very Disney-fied ending to the story there, just because it was geared towards younger audiences. So it is up to you as an educator to use your discretion for what level you think your students are ready to handle. Obviously, I don't think that Eli and Ella would really hit it off and spend the rest of their lives together. As Jake was talking before, they're more broadcast spawners. So the female would lay her eggs, and the male would just fertilize those, and they most likely die off natural history-wise. So once again, it is up to your discretion how you wanted to do that, whether topics of reproduction are inherent in your curriculum, or if you feel comfortable talking about the end of various life cycles, etc. So that is at your discretion. And let's see, sorry, I see someone has a question. Does the male eel have energy to reproduce after spending so much energy and even absorbing its intestines? I am going to let Jake type in an answer there because I actually do not know. I assume that because we do have future generation of eels born, that they are able to do that. It's probably their last contribution before they die off. So that is the end of the narrative. And obviously you can cater it to however you want. But the great thing about narratives is that you can have meaningful discussions afterwards. So for instance, utilizing the interactive mapping tool, one question I would ask was, how far was Eli's total journey? So if you were using this with your students, you would have all these different markers placed, right? And you can utilize this, this tool right here, once again, and it will allow you to create lines between each marker, and it will give you automatic distances traveled. And you can talk about with your students how this measuring the distance of his journey would be different on the interactive map maker versus measuring this on an actual paper map. So it gives you the opportunity to practice both skills with your students as well. And if you were teaching with upper grades, you could incorporate geometry and different area studies as well. There's these different tools here on these toolbar which give you that opportunity as well. You can also talk about discussion questions focused on some of the obstacles that Eli faced. What impacts could these obstacles result in? Can you think of any others? Another one you could ask is, how can we help Eli journey and make it a bit easier along the way? So that goes into more of the human impact conversations that it's important to have with children of all ages, but is specifically highlighted in the curriculum from middle school and up. So that being said, we don't have so much time left, so I wanted to briefly show you another diagram of the life cycle of eels here. And I'm assuming that these yellow arrows are indicating the European eels, who are also born in the Sargasso Sea as well. So like I said, you can really cater a narrative to any place where you live to make it more interesting, engaging, and relevant for your students. So the U.S. Fish and Wildlife Service has a couple of maps here that indicate the natural freshwater range of American eels. And as you can see, it is not only states along the coast, but is very in the heartland of the United States, which is pretty cool because it gives you the opportunity to really expand your narrative and your geography lessons as much as you want, really. Let's see. And for those of you who are more middle and high school based, there is great opportunities to expand your lessons regarding this narrative. So for instance, you could talk about angles of isolation. You can talk about wind and ocean current patterns and how that and the speed of the Earth's rotation and what these actually mean in terms of creating, sorry, let me actually get to the right slide here, creating different biomes. So it's a great way to expand your ecology units as well. You can talk about global air circulation, once again, ocean currents. We have these Hadley cells, how warm air and cool air rises and falls, and how that really creates biomes. So from elementary all the way through high school, for sure, different habitats and ecology and landscapes are part of your curriculum. So you can really go into this in great depth if you want it in as much sophistication. Some cool resources, if you go to these websites at the bottom, they actually give you live streams of wind patterns, for instance. So these are actually moving images, so I encourage you to check those out. They're very, very cool. Same with ocean currents here. So you can actually utilize these websites to go into greater depth about the migration path of the American eels. For instance, we know that when they're in their larva stage, that they are basically drifting along the ocean currents. So you can actually follow different ocean currents and how these wind patterns are affecting where the currents are going to have greater discussion about where these species end up. Okay, and also you can really go into more depth with social studies aspects as well. So this is an infographic from the World Wildlife Fund that's talking about the global importance of the Sargasso Sea, and it gets into ecosystem services, which are essentially the benefits that nature provides to humans. So that is this slide. So it's not only actually economics, but it can be cultural benefits, supporting benefits, actual products that we get, or it can help regulate bigger environmental functions as well. So for instance, if you were doing a unit on different countries around the world, you could choose one country and examine it through a historical lens to try and uncover how the country's history might have contributed to decreasing populations of American eels. Things to consider could be like conflict, economics and its connections to development and natural resource use, relationships between developing and developed countries, or globalization, technology, human population and migration. And you could have your students, for instance, write a essay where they are discussing whose responsibility they think it is to help save the species, who should get involved, etc. So there's many opportunities for you to go in much greater depth and look at the more broad scale environmental impacts of trying to conserve a species, which is quite complex, as Jake was telling you before. So there's lots of opportunities for extensions and ways to expand these for older audiences as well. And we have a few minutes left, so does anyone have any questions? Give you a minute to type that in the box. I see a few of you are typing now. Thank you, Patricia. We appreciate it. Hope you join us again for future programs. All right. Doesn't seem that we have any questions, so we wanted to thank you guys for joining in, and I hope you had a great time, and I will let Kelsey finish up.
Hi, thanks. All right, thank you all for coming. We're just about out of time, so I don't want to keep you here late. Thank you. Thank you so much to our presenters, Jake and Paloma. I hope you enjoyed it as much as I did. Just a couple things. We have a student webcast coming up next week. We're actually going to be doing a Google Hangout from the Bronx River. So if you have a classroom and you want them to attend, you can sign up right here. I'm just going to add a link into the box. You can see Jake hopefully collect some glass eels, and I'll be there too. So that's a cool opportunity to bring your classroom in, see what it's like to get hands-on with the eels. And we have some resources for you on our eels page, and we have that narrative that Paloma went through available in a Google Doc, and I've just put those links in as well. Finally, if any of you would please take the time to take our survey, we would really appreciate it. It's a great way for us to see how we're doing and get some feedback for future presentations. So thank you all so much for coming. I'm going to send out a thank you email tomorrow to everybody who attended. If you do not get that thank you email, you can email me at my email address here. And the thank you email will tell you how to get your PD certificate if you want that. Again, thanks for coming, and I will let you go to have a nice evening.